So I'm going to be breaking this section up into quite a few videos just because while the idea is pretty straightforward to how we're going to be finding volumes in calculus, it's a lot of little tiny nuances that can be a little bit much to take if I try to cram too much into one video. So it's going to be broken into quite a few. So in this video, I just kind of want to talk about the general approach that we're going to be taking to finding volumes. And the approach is dictated by the types of solids we're going to be finding. So we're going to be looking at what are called solids of revolution, where we have a region in the graph that we then revolve around a line to form the solid. And the two methods we're going to be discussing there that are covered by the AP exam are disks and washers. There's a third method I'm going to have at the end of this series of volume videos called cylindrical shells that is not covered by the AP exam, but it's kind of nice to know because it gives you a little more flexibility with some of the more challenging solids of revolution. The other is when we have solids of other cross sections, or sometimes you'll see it called solids of known cross sections. So we still have a region on a graph, but instead of being revolved, that's going to be the base of our solid, and a given cross-sectional shape is going to be stuck onto that region. So we have to think of it as it's popping out of our coordinate plane. And we solve these by accumulating the areas of the cross-sections as well. But in this case, we're going to be having cross-sections that are like right triangles, equilateral triangles, rectangles, squares, etc. In terms of how we're going to approach this, general approach to finding volume, I recommend kind of following these general steps. And one, sketch the region of the graph. It's always easier with a picture. Then attempt to sketch the solid. Please realize this is not art. So you're not being graded for artistic ability here, but it's more of if you can picture the solid, it helps you understand what the cross-section will look at. Because the next part is sketch what your cross-section looks like. And then label the dimensions of the cross-section. And you will have variables here because your cross-sections are going to be different sizes depending on where you cut the solid. And then write the area of the cross-section. That will also have variables in it because you're going to be basing it off of your sketch of the cross-section. The area of one cross-section, though, isn't what you want. You want to accumulate all of those cross-sections, and that's where integrating comes in. So in the next series of videos, we'll start exploring this process.